Once the sample has been placed in the fixture, we are now ready to do a measurement. First thing we do is ground the probe ranger. This should be grounded at the probing point of the instrument that you're going to use, and you should wear a grounding strap on your wrist. This is connected to an Agilent vector network analyzer, the E5071C. Notice that I also touched the ground connections of the probes to discharge them through my body. The network analyzer is going to have a port 1 and a port 2 cable with either 3.5mm or SMA connectors. The instrument needs to be calibrated to the measurement reference plane, and then after it's calibrated, those cables are connected to the probes. Typically I put port 1 on the left connector and port 2 on the right. After we hand tighten the SMA connectors on both the left and the right probes, we're going to use a torque wrench to make sure that we have a good electrical connection to the probe. We use a wrench to hold the connector on the probe so that it won't move, and then we tighten the SMA on the port 1 cable. This torque wrench will pop out at the desired torque, like that. We then use the microscope to view the probe tip and get it close to the sample, particularly right over the center conductor, by using the fine positions on the XYZ positioner stage. We don't really want to touch the center conductor, we want to be just above it, but it's okay to touch it as long as we back off of it. So we have a Z stage that will move the probe up and down. We have an X positioner that will move it left and right. And then there is also the Y positioner that will move it to the front and to the back. We're going to need these positions to optimize the coupling of the network analyzer to our sample. If we have great connections, we will see multiple resonant peaks, the first one at about 1 GHz and the others at multiples of those. But it's going to take some adjustment to get there. When we start, the network analyzer screen might look like this. We're sweeping from, in this case, DC to 8.5 GHz. As we move the probes closer to the center conductor, we'll start to see the peaks, the resonant modes of the sample start to set in. As we get them closer, the peaks will grow and become prominent, and then we can identify each of those peaks that we need to measure. At some point, however, if we keep adjusting too far, we'll touch the sample and all the peaks will become very broad. That's not a good measurement condition, so we have to back the probe off so it just does not touch, and they'll start looking like this. So there'll be a tiny little gap between the center conductor and the probe tip. Once we have the peaks identified, we're going to adjust the span and the scale to find the first peak at 1 GHz. Should always lie somewhere around 1 GHz. We're going to continue to narrow the span and adjust the scale so that we fill the network analyzer screen with the resonance peak. Then we use the marker functions on our network analyzer to measure the center frequency and the Q. On our network analyzer, this is the bandwidth marker functions, and it measures the Q and the center frequency, which is going to be the input to the calculator software to measure decay.